Hi everyone. In this video we're going to look at simplifying fractions that have exponents in them. In particular, we're going to focus on simplifying fractions by using factorizing. At this point, I'm assuming you're familiar with the definitions and laws of exponents. What you'll notice when you look at the definitions and laws is that generally they refer to multiplying and dividing. However, when you're adding or subtracting, these laws are not going to help you. In that case, you need to use adding-like terms. Now, before we get to simplifying fractions that have powers, let's start with what you know about fractions already. So here in my first example, I've got 5 quarters plus 3 quarters. Now, you'll know from many years ago that the way you work this out is you'll say 5 plus 3 quarters, and so that gives you 8 quarters, and 8 quarters you can divide top and bottom by dividing each by the same factor, which is 4. And so you get an answer of 2 over 1, which is 2. Now, if we go back to my second step, you'll see that both 5 and 3 are being divided by 4. So this 4 at the bottom applies to both the 5 and the 3. This brings me to my next example. Now, like in the previous example, the denominator, the value in the denominator applies to both parts of the numerator, and these two parts are being added together. So I could write this as 6a out of 3 plus 9b out of 3, and 6 out of 3 I can divide top and bottom by the factor of 3. 6 divided by 3 is 2. And 9 and 3 can divide by 3. 9 divided by 3 is 3. And I land up with 2a over 1 plus 3b over 1. Now you've learnt another way to do these. The other way that you've learnt is to factorize. So here, I could rather take out 3 as a common factor in the numerator, 2a plus 3b, and I have 3 in the denominator. I can divide numerator and denominator by 3, and the reason I can do this is because 3 is a common factor, and so I land up with the same answer. Now what you'll notice in the first example and the second example, when I divided top and bottom by the same factor, I crossed out the values. Now this crossing out represents dividing. It's important when you divide that you have one term over one term. And what I mean by one term is an expression that is made up of parts that are multiplied or divided together. So not parts that are added or subtracted. So if you look at the second way I did the question, I've got one term because I've got 3 multiplied by a group 2a plus 3b, which will be my second factor in the expression. That brings me to my next example of an algebraic fraction. Now, can you see I can't divide top and bottom by 20b and remove that from the fraction, because that's not what the question means. The only way I could really break this up would be to write something like 15a out of 10a minus 20b plus 20b out of 10a minus 20b, and you can see straight away that's not going to help me with the question at all. So let's start with a different strategy. Now, what you're going to do is, like before, I'm going to factorize so that I've got one term at the top. Now I can factorize by taking 5 out as a common factor, so I get 3a plus 4b. And in the denominator, I can factorize also by taking 5 out as a common factor, and so I get 2a minus 4b. I can now divide numerator and denominator by the same factor, which is 5. That means my fraction can simplify to 3a plus 4b out of 2a minus 4b, and that will be as far as I can go. Out of interest, you might have noticed that I didn't take the highest common factor out of the denominator. I could also do this question that way, so let's do this quickly. The numerator will be 3a plus 4b, and the denominator, if I took 10 out as a common factor, oh dear, that would be not 2a, it will be a minus 2b. Then I can divide both top and bottom by 5. And so then my simplified answer is 3a plus 4b over 2a minus 2b. And that answer is exactly the same as the previous one. It just has a bracket in. So it's up to you which way you go. This brings us to questions where we want to simplify fractions that have powers in them. Now, up to this point, you've quite comfortably simplified fractions that have powers in them. But the difference is that this fraction has two terms in the numerator. In order to apply the laws of exponents, you're going to need to have one term in the numerator and one term in the denominator. And at the moment, you don't have that. So what you're going to have to do is you're going to have to factorize. So let's factorize the numerator. Before we factorize the numerator, let me just make my factors quite clear. 3 to the power of 2 plus 3 to the power of x. At the bottom, 3 to the power of x times by 3 to the power of negative 1. Remember, this step is optional for factorizing. I just find it helps me spot the common factor quite easily. Now, in the denominator, you can't factorize because it's already factorized. You've got a product of two factors. Now what you're going to do is you can now divide numerator and denominator by the same factor, which is 3 to the power of x. That leaves me with 3 to the power of 2, which is 9, plus 1 in the numerator, and a third in the denominator. Let's just continue here. So 9 over 1 is 10. Now when I'm dividing by a fraction, it's easier to multiply by the reciprocal, and so I get 30 as my answer. In my last example, again, I have more than one term in the numerator and more than one term in the denominator. So before being able to simplify the fraction, I first need to factorize. So let's just write everything out in an expanded way so I can see what's going on here. Remember, this step is optional. I find it helpful, but if you don't want to do it, you don't need to. N times 5 to the power of 1. Now in the numerator, my common factor is 2 times 5 to the power of n. And so I remain with 1 minus 5 to the power of negative 2. And in the denominator, I also need to factorize the denominator because it's two terms. 5 to the power of n, 1 minus 5 to the power of 1, which is 5. Now I can divide numerator and denominator by 5 to the power of n. Now the questions ask me to use no calculator, so I'll have to show all my steps to finish simplifying here. So I'm going to get 1 minus 5 to the power of negative 2, 1 out of 25, over 1 minus 5 is negative 4. I have one term at the top and one term at the bottom, so I can divide numerator by 2 and denominator by 2. So let's finish up. 1 is 25 out of 25, so that will give me 1 minus a 25th is 24 out of 25. And if I'm dividing with a fraction, it's easier to multiply by my reciprocals. So let's multiply by negative a half. So 2 goes in there once, 2 goes in there 12 times, and my final answer is going to be negative 12 out of 25. So to end this video, I'd like to show you the same question, factorized just in a slightly different way. What I'm going to do is I'm only going to factorize with the 5 to the power of n. So I get 2 minus 2 times 5 to the power of negative 2 over 5 to the power of n, 1 minus 5 to the power of 1. Here I didn't show the step where you break everything up. So I can divide numerator and denominator by 5 to the power of n. So I get 2 minus 2 out of 25. 1 minus 5 is negative 4. 2 is 50 out of 25, so 50 minus 2 is 48 out of 25. Times by my reciprocal, and so I get exactly the same answer again. So sometimes you don't need to take out the highest common factor. Sometimes it's just helpful to take out a common factor that will simplify the question. In this case, by taking out 5 to the power of n as a common factor, removes any unknown values as exponents, and then I can work out the question quite easily to finish off. So to wrap up, when you simplify fractions, you need to decide if your fraction is in the format of one term over one term. So if you look at the first question, I definitely have one term out of one term. But in the second question, I have two terms in the numerator. So in the question on the left, firstly, I'll write my bases as primes, or as a product of the primes, and I've done that in an earlier video. And then once you've done that, you can use your laws of exponents and simplify your fraction. Now, if you'd like to do this question in your own time, your answer should be a third. Now, the question on the right has two terms, so it's important to factorize the numerator first. And once you've factorized, then you can simplify your question. And you'll find that your answer, if you do this question in your own time, is 2 out of 27. So as my last point, when you're simplifying fractions, look at the fraction carefully before jumping in. Is there one term in numerator and denominator, or are there two terms, and do you need to factorize first?